Hello and welcome to another video in which we continue our quest to analyse non-linear ordinary differential equations. In fact, any type of differential equation really, but particularly non-linear ones. And what we're going to do in this session is to look at the logistic equation and recognise that it is in fact a Riccati equation. It's a type of Riccati equation, and we're going to look at a particular example. So the logistic equation, and I'll just write this down, the logistic equation is usually written, and I'll write it here, as dn by dt, which is equal to, I think this is some kind of reproduction rate, growth rate. So R is a growth rate, and that's multiplied by the population at any time t, n, and that in turn is multiplied by 1 minus n over k. Right, so that is a very basic logistic Riccati equation where, as I said, R is equal to the growth rate, and K is equal to the carrying capacity. Now, what do I mean by carrying capacity? Well, if you have a geographical area like that, that geographical area determines how many people or how many of any type of life form you can have on that island, say, on that geographical area. So in this particular case, we might have a small island in a reservoir or a boating lake, and it may harbour some type of animal that cannot get above the population size of, say, 100. So that would be the carrying capacity of that island, 100 squirrels, say, in that lake. So 100 squirrels on that island in that lake, that would be the carrying capacity. The growth rate R generally indicates, well, it's related to the birth rate. I think sometimes the death rate is included in that, and then you generally have an overall growth rate as a consequence of the difference between the birth rate and the death rate. I can't remember exactly if that's the case, and you will have to do your research and find that out for yourself. But in any case, R determines the nature of the growth of the curve that results from this logistic equation, or otherwise a Riccati equation. Now, you can have modifications of this equation. dn by dt is equal to Rn all times in brackets 1 minus n over k, close brackets. In fact, actually, we'll call that equation 1, just in case we need to refer to it. As I said, you can have modifications of this equation. So you might come across, well, let's write this down. Let's get some black ink. A modification of 1 could be, I'm writing over other letters here, but hopefully this is clear enough for you. So modification of 1 could be dn by dt equal to Rn times 1 minus n over k minus, well, we call this k2. So this may be another factor brought in to the logistic equation, which, for example, results in a further decline in that population. Or you might have a plus sign here to indicate that there's something else that's causing the population to increase beyond the ordinary growth rate, and so on and so forth. Now, what we're going to do is we're going to look particularly at this equation here, which we'll call 1a, because I haven't named it 1a. Let me make that plainer. I haven't named that, I haven't labelled that with any particular, I haven't labelled it as 1a in my notes, so I don't want to get what I'm about to write confused with what I've already written in my notes. So we just call that 1a for now. So we're going to look at a certain form of this equation and solve it in its entirety, and so we'll make a start with that. So if we go on to the next page, then we're going to look at solving. So we want to solve the Riccati equation, otherwise known as the logistic equation or modified logistic equation. dn by dt equals 8n. And I've just plucked these figures out of thin air, but it will hopefully give you some idea of how to solve these equations, because obviously it doesn't matter what the values like 8 actually are, so long as you know the method by which to solve the equation. And in the parentheses, in the brackets, we've got 1 minus n over 2, close brackets, and then we're subtracting 3. So this might be like migration. There might be 3 people migrating out of the geographical area. I mean, that's just an example. Anyway, so what we have to do is solve this equation. Now we'll call that equation 2, right? So rewrite the equation. So we rewrite equation 2 as well, we can go through each individual step. So we've got dn by dt is equal to 8n. If we multiply out the brackets, we've got 8n minus 8n squared divided by 2 minus 3. And that simplifies to give 8n minus 4n squared minus 3. Okay, so bring everything onto the left-hand side to get dn by dt. What have we got? We put the 4n squared there. Then we've got the minus 8n and the plus 3. You see what I've done? I brought the minus 4n squared over to the left-hand side, so it becomes plus 4n. I brought the 8n over to the left-hand side, so it becomes minus 8n. And I brought the minus 3 over to the left-hand side, so it becomes plus 3. And all of that is equal to 0. And we're going to call that equation 3, right? Now, what we do is, I'm going to write this in green. We put some unknown value, which we'll call u, equal to e to the power, and we use this value here, whatever that value is. In this case, it's plus 4. we write 4 up in the indices part of that exponent times the integral from 0 to t of n dt, right? So we'll call that equation 4, right? So u is equal to e to the power of 4 times the integral of n dt, right? Right. Now let's do this bit in green. So the derivative of u with respect to t is u dash, well, u prime. So u prime is the same as du by dt, and that's equal to u prime. And then, say, if we differentiate whatever is on the right-hand side of equation 4, we get 4n e to the power of 4 times the integral of n dt, and that really should go from 0 to t, right, like that. Now we know what this actually is, this exponential box. We don't leave it like that. We know that e to the power of 4 times the integral of n dt is equal to u here. So we rewrite that as, well, we'll write it as 4n u. And we call that, let's write in black ink, try and keep consistent with colours, which I'm not always consistent. So that's equation 5. So we'll just write it a bit more clearly. U prime equals 4nu, okay? And from now let me just look at my notes. Okay, so let's go on to the next page. So just one moment whilst I pause to look at my notes, and I'll be right back with you. Well, welcome back. Yes, I figured out I'd made an error in my notes, and in my notes I'd had an n prime here, and I was wondering how to get to the next stage before I then realised that this should be a u prime. So actually I wrote down the right thing here, u prime, but we need to do something with this equation. So what I'm going to do is I'm just going to delete this line here, and I'm going to write equation 5 down here because we don't want to make any mistakes if we can help it. So if we go on to the next page, from equation 5 we get, whoops, bit of a squiggly get, we get, well, if we look at that, we can write n in terms of u prime over 4u. So we get n equals u prime over 4u. And that is equal to equation 6. Let me just check that. Yep. So it looks like we're on the right tracks. Now then, if we just go back again to equation 5, we've got u prime equals 4nu. We need to differentiate that again to get u prime prime. So we'll work out what that is. Since from equation 5, we have u prime equals 4nu, then u double prime is equal to 4. So first of all, we'll leave the 4 alone because that's just a constant. We can bracket it if you like, and then differentiate what is in the bracket. So we've got, basically we use differentiation, what do we call it? We use a product rule. So we use a product rule to differentiate this. So we leave the n alone, and we differentiate the u, and then we differentiate the n, and we leave the u alone, okay? Now that is equal to 4nu prime plus 4n prime u. Right, okay, so what do we do now? We need to make another substitution, so I'll just write that out again a little more neatly. So we've got u double prime equals 4n u prime plus 4n prime u. So what we find is that, if I can read my notes properly, we've got from equation 5 once more, from equation 5, we have u prime equal to 4nu. So this equation, which we'll call equation 7, becomes u double prime equals 4n times 4nu plus 4n prime times u. And so we've got u double prime equals 16n squared u plus 4n prime times u. And we call that equation 8, okay? Now, we have to simplify equation 8. So, making n prime the subject of equation 8, we have n prime equal to u double prime minus 16n squared u, all divided by 4u. So let's just go back. We take the 16n squared u, which is this term, over to the left hand side, and then we divide by 4u, right? And that gives us what n prime is. So we'll call this equation 9. And I'm trying to pay close attention to the labels that my equations have. So that was 8, 6, 7, 8, 9. Thus, if we substitute equation 9 into equation 3, we get, there is another substitution that we need to do with the next equation that we're about to get, but I'll do that when we've written the next stage down, and then hopefully it won't be as confusing. So we know that dn by dt is equal to that, and our equation 3 is, we'll just write this in green. So we've got dn by dt plus 4n squared minus 8n plus 3 equal to 0. Right, so we substitute all of that in to there, right? So we'll just make the page look a bit neater. So what we've got is u prime prime minus 16n squared u, all divided by 4u, plus 4n squared minus 8n plus 3 equals 0. Okay. Now I haven't given that a label at the moment, that equation, but what we do is let's just get rid of the stylus, multiply both sides by 4u to get, and on this side we get, I'm going to write it in red, we get u double prime minus 16n squared u. That doesn't look very neat, does it? U double prime minus 16n squared u plus 4n squared times 4u minus 8n times 4u plus 3 times 4u, and that's equal to 0. Okay, so simplifying, we get u double prime minus 16n squared u plus 16n squared u minus, well, let's just go back to the previous page. So we've got minus 8n times 4u is minus 32nu. I do wish I could find the nib of my pen. So minus 32nu. And then let's go back to the previous one. So we've got plus 3 times 4u, which is 12u, plus 12u equal to 0. And I have actually labelled that equation 10. So that's equation 10. So you can see that this begins to simplify when I can actually find the nib of my pen. So that cancels with that. And what we're left with is, so let's change to black. Thus, we are left with, and we'll write this in blue, we're left with u double prime minus 32nu plus 12u equal to 0. And I haven't given that a label, but you might remember that from equation 5, let's go right back to equation 5, we have this term here. So now we substitute in for n. I think we might have actually worked that out at some point. So let's just have a look. Yes, so from equation 6, we've got that expression. So from equation 6, n equals u prime over 4u. So I'm actually going to label this equation. So we'll call that equation 11. So equation 11 now becomes u double prime minus 32 times u prime over 4u. That is a little bit scrawly. U times a u plus 12u equals 0. Right, so simplifying, you can see that the u's cancel and 32 divided by 4 is 8. So we have u double prime minus 8u prime plus 12u equal to 0. And I'm going to, again, I'm going to give that a label. So we call that equation 12. And we're going to write it down again on the next page. In fact, actually, let's cut and paste it. So I'm going to cut and paste equation 12. Let's try again. Okie doke. There we are. Add to new page. Right, okay, so we've got that equation 12 there. Now, how do we solve equation 12? Well, it's quite easy to solve equation 12 if you've done A-level mathematics. This is easy to solve. Okay, what we do is we let's choose a different colour. Let u equals, I don't think I've used the letter A, have I? So we'll call it A times e to the mt. So that u prime equals m a e to the mt and u double prime is equal to m squared a to the e mt. Therefore, we'll put therefore 12 can be written as can be written as m squared a e to the mt minus 8ma to the e to the mt plus 12a e to the mt equal to 0. And we'll call that equation 13, right? Well, as you can see, the A's and the E's all cancel, leaving us with change back to that, leaving us with the quadratic equation m squared minus 8m plus 12 equal to 0. I would call that 14. So let's go on to a new page. So we've got m squared, let me just look at the previous, minus 8m plus 12, minus 8m plus 12 equal to 0. We said that was equation 14, didn't we? Let's call it equation 4. I should have just cut and pasted it. I don't know why I didn't do that. Anyway, this is easy to factorise. Right? So if we factorise it, then we've got to find all the factors of 12, which when added together give minus 8. So we can have 1 and, well, we can't have 1 and 6, or rather 2 and 6. We can't have 2 and 6. 2 6s are 12. Oh, actually, we can. I'm stepping ahead of myself. What I wanted to say was we can't have 1 and 12 because the sum of 12 and 1 is not minus 8. Likewise, we can't have 3 and 4 because 3 and 4 gives 12, but the sum of 3 and 4 does not give minus 8, regardless of what the signs are. But we do find that we can have 2 and 6 because 2 6s are 12. So we know at least one of these has got to be, we know either have got to be negative or either have got to be positive. So we either need an m minus 2 times an m minus 6, or we need an m plus 2 times an m plus 6. Well, if you think about it, this term is minus 8, right? So therefore, we know we've got to have minus 2 and minus 6 because a minus 2 times a minus 6 gives a plus 12, and a minus 2 minus 6 gives a minus 8. So the roots of that equation are m equals 2 and m equals 6. Right? So those are the roots. This means that, we'll change to blue, this means that, and we have to go back to our equation here, to equation 12. A general solution to equation 12, did I say that was equation 12? Yeah. Is u of t equal to, we'll call it alpha. There's always a constant of integration. So we'll have alpha times e to the 2t plus beta e to the 6t. Right. We're nearly finished now. So we've actually got to find what n is. If you remember, the original equation was in equation, well, basically in equation 3. This is equation 3 is the equation that we were solving, and that's in terms of n and t. And we know that u is equal to e to the power of 4 times the integral of n dt in equation 4. So we equate equation 4 with the general solution u. So let's go on to the next page. Since from, did I call that equation 5? Yeah. So from equation 4, u equals e to the power 4. Let me just give myself more room. So since from 4, u equals e to the power 4 times the integral of n dt, and that should go from 0 to t, right? Then we go to the previous page. We'll call this equation 15. Then equating this with equation 15, we're actually substituting it in, really. We get e to the power of 4 times the integral of n dt, the limits are 0 to t, and that's equal to alpha e to the 2t plus beta e to the 6t, right? But we need to get this equation, which we'll call equation 16, in terms of n alone. At the moment, n is implicit in that equation. Have I got the right equation number? Yeah, 16. So at the moment, n is implicit. We need an expression that is equal to n. Right, so what do? Well, we take logs. I'll keep this in red. Taking logarithms, and I'm going to use natural logarithms. Taking logarithms, we get 4 times the integral from 0 to t of n dt equal to the logarithm of alpha e to the 2t plus b e to the 6t. Right? We'll call that equation 17. Now, we still haven't got n on its own, so what do? Well, we differentiate. We differentiate both sides. Where's my pointer gone? So differentiating both sides of, did I say that was equation 17? Yeah, we get, well, we just get, let's write it in green. We get n, because, well, let me write it out properly. So we've got the derivative of 4. Let me see. Let me just go back. So we're going to take the derivative d by dt of both sides of equation 17, right? And what I'm going to do is I'm going to cut and paste that, because that should be okay. It's a little bit chopped off. We'll just add it to a new page. Right, okay. So we've got our new page there. So we're taking derivatives of both sides. Oops, Let me just, right, okay. So we'll just write that down. Taking, or in actual fact, we're differentiating both sides of 17 we have, and you've seen it there already. So if you differentiate an integral, you just get whatever is in the integral, which is n. So we've got n of t, because it's a function of t, is equal to, well, when you differentiate a logarithm, whatever is inside the logarithm goes on the bottom of what is now a fraction. So let's just draw a dividing line. So we've got alpha, let's try and be a little bit neater. Alpha e to the 2t plus beta e to the 6t. Right, now we need to differentiate, basically, we need to differentiate this term and this term, right? So let's do that. So when we differentiate the first term here, we get 2 alpha e to the 2t plus, and then the beta e to the 6t differentiates to give 6 beta e to the 6t. Now we can simplify this a bit more. Oh, by the way, I've made a slight error. I've forgotten to include a 4 at that side, because this 4 comes outside the derivative sign, right? So we keep the 4 there. And we'll just call this equation 18, right? So now we'll just simplify that a little bit more. We're basically there, but we'll just simplify it in a slightly better detail. So let me cut and paste that. Right, add to new page. So we've got, so n of t is equal to 1/4 times, I'm going to put big brackets in because I'm going to start factoring out some of these e terms. I'm going to take out the e to the 6t term on both the top and the bottom. So in actual fact, what we'll have is 1/4 times e to the 6t over e to the 6t. Now I know that cancels, but we'll do that in a minute. And what we're left with inside the brackets is 2 alpha e to the 2t minus 6t plus 6 beta. And in the denominator of that expression, we've got alpha e to, alpha e to the 2t minus 6t plus beta. Just beta. And of course, that simplifies because those two cancel, and these simplify to minus 4t, right? Thus, we have and I'll write this in red for you, n of t equals 1/4 times, in brackets, let's just get rid of that stylus for now, in brackets 2 alpha e to minus 4t plus 6 beta. Oh, we could take out a 2 as well, couldn't we? So in actual fact, let's just go back. Right, I'm just going to simplify it here because it saves simplifying it. Again, so we've got 2/4 there. We've just got 1 there now, and we've got 3 there. So let's just erase that and erase that. Okay, so we've got 1/2 times, in brackets, let's just I think that's okay, plus 3 beta over alpha e to the minus 4t plus beta. And that is the answer, right? So that is the analytic closed form solution to the original logistic or Riccati equation in equation 3 here. So I hope that has been reasonably clear for you and helpful indeed. Please do come back and look at more of my videos, and until next time, I'll bid you farewell for now and take care. Okay, cheerio then. Goodbye.